Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Arduino Epoch Learning Center, Project 14, getting started with the analog keypad. So for this project, we're going to use the LCD, we're going to use the keypad. The labelings on the keypad are very small. This is pin 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Sorry, buttons. 1, 2 through 9, and then 0. And we connect the ADC K pin right here, analog keypad ADCK, to the A3 line on chip A. And what we're going to do is we're going to turn the LCD on. So we're going to turn the LCD pin, LCD power pin, to the on position. And this is the quick connect, which connects the GPIO pins 4 through 9, 4, 5, 6, 7, 8, and 9 on chip A. It's just a quick connect. We're going to switch all those on carefully with a proper little screwdriver. We are now set up for our project. So let's load project 14 onto this bad boy, and we'll power it up. If you've been following along with the previous projects, this shouldn't be difficult for you. We write to the LCD, we sample the analog to digital pin that's connected to the keypad, the ADCK pin, and we have a very simple decoding routine that takes the analog value that we sample and decodes it and turns it into a button value. So what I'm going to do is I'm going to press all the buttons. It's from 0, 9, 8. Look at how the numbers are decrementing. 7, 592, 495, 409, 330, 252, 175, and 93. Now remember, we're going to see anywhere from 0 to 1023, 0 being 0 volts, 1023 being the full scale 5 volts. And using a very simple routine, we're going to take those analog numbers and use it to determine what button is being pressed. Check out the code. It's available to everybody until this campaign ends. And so, yeah, so next, how this works is there's a resistor divider. Now, that might be Greek salad to you if you have no concept, and that's why at the end of this campaign we're going to talk about it in the schematic review. But a resistor divider, you can Google it, and it's very simple. We have a very large resistor divider, a ladder, and each of these buttons is connected to a different resistor in that divider, in that ladder. And when we press that button, press any button, it's going to connect that corresponding resistor divider value and send it to the ADCK pin, which is connected to chip A on the A3 line. And it's going to sample that. So we can make a resistor divider that has 2 resistors, so we can get 5 volts, 2.5 volts, and 0 volts. Or 3 resistors or 4 resistors. They're all in series, and between every resistor you can sample a different voltage. Resistor dividers are great. I love the analog to digital the analog keypad more than the matrix. The matrix requires 8 GPIO pins for a 16-button matrix keypad. This requires only 1. It requires maybe a little bit more code, maybe a longer process. It certainly takes a longer processing time, but I use it anytime because it takes one wire. That's it, 1 GPIO pin. It frees up everything else. So we will obviously do a project with the matrix keypad, but not right now. Our next video will be creating a security circuit. We're going to implement we're going to make a combination lock. We're going to implement the analog keypad, the LCD, probably the state dip switch, which we haven't used yet, and the relay and EEPROM memory. And EEPROM memory is great because we're going to use that for a ton of projects in the future, including how to save RFID card data to the chip when it powers off. EEPROM stands for electronically erasable programmable memory, I believe, off the top of my head. I think that's it. In any case, the next project is going to be a bit more complicated than this one, but as with every program, I'm going to fully comment it, and I hope you can follow along. And yes, again, at the end of this project, once everything's shipped and I have the time, I'm going to create a series that talks about all the different schematic diagrams on this entire thing so that you can understand how everything's working from an electronic hardware standpoint. Thanks for watching, everyone. I hope you have a wonderful day. Check out the Kickstarter link below.